Hello, thanks for joining us today. On behalf of the Environmental Finance Center Network, welcome to our webinar on lead line replacement. My name is Tess Clark. I work here at the Syracuse University Environmental Finance Center, and we'll be getting started in just a minute, but first there are a few logistical items that I wanted to mention. First, everyone is going to be on mute just to ensure audio quality. If you have a question, just type it into the GoToWebinar question dialog box anytime throughout the session. All of the questions will be reserved for a Q&A at the end, but feel free to send questions at any point. We will be making today's slides available as well as a video recording on the EFCN website. You can reach that website at www.efcnetwork.org. And all of our webinars can be found under the Past Events tab, and we also send out a link to the recording via email. So if you registered for this webinar and you want to watch the recording or send it on, you'll get an email with a link that you can forward to others. We do not submit our webinars to licensing agencies for pre-approval of continuing education credits. However, we do send certificates of attendance as a courtesy. If you have joined this webinar with the intention of using it to support CEU hours or PDH hours, please know that we can only give you a certificate after we verify attendance, and that it can take 1 to 2 weeks to send out the certificates, and you must attend the entire 60-minute webinar to receive one. You must be viewing the slides and listening to the audio. Again, we can't guarantee that our webinars will meet the criteria for CEUs or any continuing education for any given agency. If you have other questions about this, you can always email us at smallsystems@syr.edu. Now for a little bit about us. The Environmental Finance Center Network provides training and technical assistance to small public water systems in all U.S. states and territories to help local water systems achieve their goals and stay in compliance with the Safe Drinking Water Act. As you might guess, the EFCN is a university-based network. You can see a list of all of our network members here. We work together to create solutions to difficult how-to-pay issues of environmental protection and improvement. And on that note, I'd like to introduce John Sullivan from the Great Lakes Environmental Infrastructure Center at Michigan Tech. John is a senior research engineer with the GLEIC, as well as with the Center for Technology and Training at Michigan Tech. So thanks, John, so much for joining us. And I'm going to go ahead and pass screen control over to you.
Thank you. Welcome all to this. We're going to talk about lead service line replacement today.
So it looks like, oh, perfect, great.
Yeah. Something's happening. Oh, I got it. So why is lead a problem? Lead can cause a variety of adverse health conditions when people are exposed to it at elevated levels. Young children, infants, and fetuses are particularly vulnerable to lead because the harm appears to be greater at lower exposures in children than in adults. Lead exposure can harm children's brain development, contributing to lower IQs, as well as learning and behavioral problems. So why is lead service line replacement important? This is all about reducing the risk to lead exposure. The goal is safe and reliable water. Even if your community has a water system with effective corrosion control and low drinking water lead levels, lead service lines can contribute on predictable and variable sources of exposure. For homes with lead service lines, the service line typically contributes the greatest percentage of lead to the tap. With the reduction of lead in new plumbing material, the next large opportunity for reducing the risk of exposure to lead in drinking water is the removal of those lead service lines. So how does lead get into the drinking water? It enters when the pipes and plumbing fixtures that contain lead corrode, especially when the water has high acidity or low mineral content. Lead in drinking water can be a serious problem. The crisis in Flint, Michigan has brought this issue to our attention at all levels. Corrosion control programs and public water supplies are critical to protecting public health. Water quality practices in the home are also extremely important for homes with lead service lines, with lead solder on pipes, and with those homes with brass plumbing fixtures that contain lead. So what is full lead service line replacement? It's eliminating all the lead pipe from the water main up to the interior plumbing of an individual home and installing new pipe that is lead-free. Typical definitions for your service line means the pipe from the discharge of the corporation fitting to the service line piping or to the building plumbing at the first shutoff valve inside the building, or 18 inches inside the building, whichever is shorter. A lead service line means either a service line which is made of lead or any lead pigtail, a lead gooseneck, or other lead fitting that is connected to the service line. This is a service line diagram that we're familiar with here in Michigan, where the water meter is typically in the home to minimize freezing possibilities. And typically the service line has, a 5 to 6 or 7 foot bury, in fact, to minimize freezing in Michigan. The diagram here shows the corporation stop connected to the main, and then that gooseneck, many times that is a chunk of lead, especially in older service lines servicing older homes. And then you've got your service line running from that point to the home, and you typically have a curb stop at the property line. In the home, you normally have the water meter and a shutoff valve, and then all your internal plumbing. We've got a listing of the history of the federal lead regulations and the lead copper rule. Today I will be referring to the federal rules, regulations, and requirements, unless I refer to a specific state's requirements. But in 1986 came the lead ban. In 1988, there was a Lead Contamination Control Act. In 91, the lead and copper rule. In 2004, there were some minor revisions to the lead and copper. And in 2007, some more revisions. And then in 2011 came the Reduction in Lead in Drinking Water Act. And that's when the definition of lead-free changed from the weighted lead content of 8% or less to a weighted average of less than 0.25% for surfaces in contact with potable water. And this rule of 2011 became effective in 2014, so there was some time allowed to get some of the products off the shelf. So why the concern with lead service lines? The 1986 federal law prohibited use of materials that were not lead-free in public water systems. This was done for public health reasons, as the goal is safe and reliable drinking water. Sources of lead in drinking water. You've got your brass faucets and plumbing fixtures. From 1986 to 2014, brass faucets and fittings sold in the U.S. were labeled as lead-free, but they could contain up to 8% lead during that time period. Then we've got the lead goosenecks, or pigtails, as they're called sometimes. These are small connector pipes that are used by some communities, that were used by some communities to connect a galvanized steel service line to the water main. And then we've got our lead solder on copper pipes. And lead solder was used on copper pipes until 1986, when it became outlawed. And then you've got your lead service line. Lead service lines are found in many older communities. Local ordinances impacted the type of pipe material used in communities at specific times. The use of lead goosenecks and lead service lines in potable water systems seems to have ceased by 1960. And most suspect service lines for lead are those installed previous to 1940. So it's the older neighborhoods, the older homes, where it could be most suspect to have that lead service line and lead gooseneck. Service line material is typically, one of these four materials shown in the slide. The galvanized steel, lead, copper, plastic. The local construction practices and ordinances impacted the type of material used in communities at specific times. A simple test can be performed to determine if a gray color pipe is lead or is it galvanized steel. And that test is using a magnet, a little simple refrigerator magnet, and a screwdriver or a coin. If the magnet sticks to the pipe, it is galvanized steel. If the magnet does not stick to the pipe and the scratch surface is shiny silver, it is lead. The magnet will not stick to copper or plastic, of course, and the copper penny, the copper pipe usually looks like a tarnished penny. There's two types or sources of lead in drinking water: particulate and dissolved lead. The particulate is typically random and unpredictable, caused by physical disturbances such as hydrant flushing, service line replacement, road construction could make some disturbance in your water system, and then, of course, corrosion. Then the dissolved lead is typically reasonably well characterized. It's dependent on the water quality, the surface area of the lead, and stagnation time of the water in the system. I've stated this health concern previously, but it's worth repeating that lead can cause a variety of adverse health conditions when people are exposed to it at elevated levels. Short-term exposure can cause interference with red blood cell chemistry and cause delays in normal physical and mental development in babies and young children. And that's why we're so concerned about lead. So the lead and copper rule. There were revisions in June of 1991 that established an action level of 0.015 milligrams per liter for lead and 1.3 milligrams per liter for copper based on the 90th percentile level of tap samples. An action level exceedance is not a violation, but can trigger other requirements. That 90th percentile level, if you have 2 to 5 samples, the average of the 2 highest is the 90th. If you have 10 samples, the 9th highest is the 90th percentile, and etc. So, action level exceedance. That will require one or more of the following actions: water quality monitoring, corrosion control treatment, public education, and then what we're talking about today is lead service line replacement. The federal requirement to identify lead service lines is each system shall identify the number of lead service lines in its distribution system based on a materials evaluation. The purpose is to identify a pool of targeted Tier 1 sampling sites. Tier 1 consists of single-family structures that contain copper pipes with lead solder installed after 1982, or contain lead pipes or are served by a lead service line. So that's what we're looking for, trying to nail down some Tier 1 sampling sites, those single-family structures that contain that could have the lead in their system, in their service lines. That's the goal. Materials, there's materials evaluation. Sources of service line information are typically your construction plans and specifications, as-built drawings, plumbing codes, plumbing permits, the plumbers who are doing the work. These are sources of that information as to what the material is. You can look into inspection and maintenance records. And then also there's interviews with senior employees, retirees, building and plumbing inspectors, active and retired, and residents, especially your older residents in those older areas of the community, or older residents that may have moved into a senior citizen complex, and they might be able to give you some information as to what they've seen in the past. Because construction is always interesting to people, and they may have been there to observe what was happening. It's important to know that there's no requirement to dig or excavate to determine the service line material. You just have to go through an evaluation process and make a determination. If you just don't know what that material is, it's best to say you're not certain. It's an unknown material and listed as such. Sampling for lead and copper. Initially, systems need to monitor during 2 consecutive 6-month periods. When lead and copper action levels are not exceeded, the sampling may be reduced to annually, and the number of sites to sample may be reduced with state approval. system sizes and the number of people served. Here I show in the slide, a large system is typically that with a population of more than 50,000, whereas a medium-sized system is referred to as the one that's from 3,300 to 50,000 population. Then the small systems having less than 3,300 people served. So the number of sampling sites for communities of various sizes is shown on the following slide here. So this shows you the number of sites that you need for tap samples. If your system size, the number of people served, is over 100,000 population, the number of sites would be for tap samples would be 100 for reduced monitoring, and it does take state approval to do the reduced site monitoring, and we'll talk more about that in the next slide. But reduced monitoring can be cut in half, down to 50. So that population of 10,000 to 100,000, 60 sites are required. A reduction can be down to 30. And the more medium-sized communities, 3,300 to 10,000, still need 40 sites with a reduction to half of that, 20. The smaller communities, 500 population to 3,300, 20 sites for tap samples, and a reduction to 10. And the very small communities, 100 to 500, you'd need 10 tap samples with a reduction to 5. And if there's less than 100 people served, you need 5 tap samples as a minimum. There's no reduction for the small, ultra small community. You got to monitor in order to monitor every 3 years, any water system that maintains a range of values for the water quality control parameters reflecting optimal corrosion control treatment specified by the state for 3 consecutive years of monitoring may reduce the frequency of monitoring from annually to once every 3 years if it receives written approval from the state. Systems sampling annually or less frequently shall conduct a lead or copper tap sampling during the months of summer months, June, July, August, or September, unless the state has approved a different sampling period. Lead service line replacement requirements. Any system exceeding that lead action level after implementation of applicable corrosion control and source water treatment requirements shall complete the lead service line replacement requirements. So it's only after you can't control your lead with corrosion control or source water treatment requirements is when you need to get into the lead service line replacement. Systems that fail to meet the lead action level in tap samples after installing that corrosion control and or source water treatment shall replace lead service lines annually at least 7% of the initial number of service lines in its distribution system. For example, if there were 500 lead service lines determined initially, 7% would mean replacing 35 lead service lines per year as a minimum. Thus, a 15-year program to replace all the lead service lines. That's the federal requirement. That initial number of lead service lines is the number of lead lines in place at the time the replacement program begins. The system shall identify the initial number of lead service lines in its distribution system, including an identification of the portion owned by the system based on that materials evaluation. And we already talked about the materials evaluation. A system is not required to replace an individual lead service line if the lead concentration in all lead service line samples from that line is less than or equal to that 0.015 milligrams per liter. This is a federal rule. However, Michigan is one state that is requiring all lead service lines be removed at the rate of 5% per year as a minimum. Several states are now requiring community water systems to submit information on the lead service lines in their system. 4 of those states are in the Midwest. Illinois, Michigan, Ohio, and Wisconsin. The federal requirement is that a water system shall replace that portion of the lead service line that it owns. Where the water system does not own the entire service line, the system shall notify the owner of the line that the system will replace the portion of the service line that it owns and offer to replace the owner's portion of the service line. And this is only for homes where the tap samples exceed at 0.015 milligrams per liter, or 15 parts per billion. A system is not required to bear the cost of replacing the privately owned portion of the line, nor is it required to replace the privately owned portion where the owner chooses not to pay the cost of replacing the privately owned portion of the line. It's a sales job, and people need to be convinced that they should be doing this because we want safe and reliable water delivered through our systems to the homes and to the people residing therein. There's a notice that has to be given for partial service line replacement. If the entire length of the service line is not replaced, the water system shall give a 45-day notice to all residents of all buildings served by the line, explaining that they may experience a temporary increase in lead levels in their drinking water. And then they should also be given guidance on measures consumers can take to minimize exposure to lead. And those typical guidance is to advise the use of water filters, cleaning of the cold water faucet aerators, and flushing the water lines before use. That's the cold water line. There are sampling requirements for partially replaced service lines. The system needs to inform the residents served by the partially replaced line that the system will, at its expense, collect a sample from each partially replaced service line that is representative of the water in the service line for analysis of lead content. This is to be done within 72 hours of the completion of the partial replacement of the service line. The system shall report the sample results to the owner and residents served by the partially replaced service line within 3 business days of receiving the results. So where are the lead service lines? At the time of the adoption of the lead ban in 1986, there were estimated to be 10.2 million lead service lines in the United States. There's no national database of all the homes with lead service lines. Individual water utilities may have maps of lead service lines for their network, but no one has a complete nationwide assessment. Although the American Water Works Association, AWWA, has performed a survey on the number of lead service lines in use. So this 10.2 million was an initial estimate back in 1986. So where are these lead service lines? A 2016 survey, or actually a report by WWA, indicated 6.1 million complete or partial lead service lines remain in operation, probably serving 15 to 22 million people, roughly 7% of the population of the United States. It's estimated that 30% of community water systems have some lead service lines in their system. Many of these lines were found in the northeast, with an equal number being found in the south. The majority of the 6 million lead service lines still in use are found in the Midwest. Areas with homes built prior to 1960 saw the greatest number of service lines. The states of New York and New Jersey estimate 80% of the homes are on public water systems. 80% of the homes on public water systems in those states have lead service lines. Here's the estimated number of lead service lines, and this is done. These numbers were based on actual surveys done in 2011 and 2013, and then communities were surveyed. And there are actually about 1,000 communities that turned in results of these surveys, and then through statistical analysis, they come up, or the people, Cornwell and others created this report and came up with these numbers. And their report is available online. It's not uncomplicated, but it's very thorough. So what they came up with in EPA regions 1 and 2, the smaller population communities, less than 10,000, they've estimated there's probably 10,000 lead service lines in all those smaller communities in regions 1 and 2. And with the more mid-sized communities, 10,000 to 50,000, they estimate 870,000 lead service lines in those 2 EPA regions. Then the larger communities, greater than 50,000 in population. They've estimated 160,000 lead service lines in those communities for a total in those two regions, EPA regions, of 1,040,000. The big number there is in regions 5 and 7, which is the Midwest. The smaller communities, less than 10,000 population, 460,000 lead service lines estimated. The mid-sized community, 10,000 to 50,000, 940,000 lead service lines estimated. The large community, greater than 50,000, 1.98 million lead service lines estimated. And I emphasize estimated. For a total in those two EPA regions in the Midwest of 3.38 million lead service lines. This shows where the those EPA regions are. Those shown in red are not they're not Trump states. They're hot states for lead. It's the Midwest, EPA regions 5 and 7. They're all color coded here to look at. So it's the Midwest regions 5 and 7, which have the most lead service lines estimated. And the fewest lead service lines are out west in EPA regions 8, 9, and 10, shown in blue. So those three regions have that smaller number that we can go back and look at. Those so regions 8, 9, and 10 in the smaller communities, less than 10,000, there's estimated 120,000 lead service lines. The next size community is 10,000, and then the larger community 130,000, for a total of 250,000. So the least number of service lines is estimated to be there in that the far west. This pie chart shows clearly where the greatest number of lead service lines are estimated to be. The Midwest in red has that big number, and the West in blue, the lowest number of service lines, lead service lines. Again, all estimated. So 6 million is the latest estimate for the number of lead service lines in existence. The information presented in this slide was prepared by the Environmental Defense Fund. And they say, you know, why replace them? You want to reduce the children's exposure to lead, is why we're doing it. There's a general consensus that it should be done. Communities that have lead service lines, Flint, Michigan, Newark, New Jersey, you know, there's a lot of people really upset the fact that those lead service lines are not being replaced fast enough. There's definitely a national consensus to do it, protect the health. But the big challenge is funding the replacement on private property. When the Environmental Defense Fund looked into it, they found that they studied 13 states with 2/3 of the lead service lines, and they found no barriers to use of the public funds to replace the lead service lines on private property. And they assume that other states have similar laws or policies, so there's probably no prohibition of spending public funds on private property. But it's still a legal authority question, spending public money on private property. Partial replacement is inefficient and can exacerbate exposure to lead. Some states have provided grant funds to do the work on private property, as well as, of course, in the public lead service lines, the public portion of the lead service line. And some states are allowing the use of the EPA capitalized revolving loan fund money for lead service line replacement on private property. Michigan is one of the states using their revolving loan fund money for lead service line replacement. They're allowing the revolving loan fund money to be used for total replacement of lead service lines, both on public and private property. They allow, as being eligible for funding, the purchase of the related easements if it's determined that's the way it should be done. They'll fund the collecting of field information and also homeowner education and coordination, all eligible for the funding in Michigan. The following slides will talk about a very successful program in Lansing, Michigan, where they did total lead service line replacement. This is in Lansing. It's their Board of Water and Light, which is responsible for the water system, and they. The following slides will show the process and procedures used by the Board of Water and Light in Lansing to replace their lead service lines. The replacement started in the 1990s and was completed in 2016. The total number replaced was 12,720. The major lead service line replacement was done in that period 2004 to 2016, when 12,150 of the service lines were removed. The cost during that last 10 years of the removal was about $44.5 million, and that comes out to an average cost of $3,700 for lead service line in that period of time. And that's already a few years ago. In Lansing, the utility owned the full service line from the transmission main in the public right-of-way to inside the home at the water meter's location. And most meters were inside of homes. So they didn't have the problem of securing easements or getting permission. They, of course, communicated with the people as to what they're going to be doing, but they did it all with their financing. The Lansing Board of Water and Light serves more than 56,000 residential, business, and industrial water customers. Thus, approximately 25% of the service lines in Lansing were lead, and they were all removed. They have a standard for lead service line replacement. A trenchless cable pulling method is what they used very successfully. The application was the replacement of the existing service lines with a new copper tube service line using a trenchless construction technique, which replaces the old service line using the existing route. Service line replacement is performed with the expectation that the existing service line will be removed. standard references construction techniques that replace the service line using the existing route. A cone-shaped tool, sometimes called a pulling block, locks onto the trailing end of the service pipe. The cone plus the pipe is pulled from the ground by a cable passing through the pipe and attached to the cone. The replacement pipe is simultaneously pulled in behind the cone. This technique, they've found, cannot be used if the service line is looped, badly clogged, or encased in concrete, or if existing utilities interfere with a straight line pull, or if the ground is extremely hard to dry. But they were able to use it on the vast majority of their lines. And they found that generally service line sections greater than 60 feet cannot be replaced using this technique. So the following slides will present the photo along with a narrative of the Lansing Board and Water Light process. This is a great technique where it can be used as it minimizes the disturbance of private property, which can become a major issue and a people problem during excavation and restoration phases of that service line replacement. So here's a slide that shows the process begins by shutting off the curb stop to prevent any water in the system from entering the customer's premises. This is especially important to minimize the transfer of any lead particulate into the service or the customer's household piping during the excavation of the corporation at the main. This slide and the following slides were provided by the Lansing Board of Water and Light and are used with their permission. Once the curb stop has been closed, the work can be then divided into two different work groups. The first work group can enter the premises and disconnect the service from the meter assembly. The second work group can then begin the excavation process at the main to expose the corporation fitting. Excavation can be accomplished with either a backhoe or by using a vacuum excavator. The advantages of the vacuum is that it can minimize the potential risk to other utilities that could be difficult to locate or may have been mismarked. Of course, there's also a lot of hand digging which must be done. Oh, excuse me. Sorry about that. Once the corporation is exposed, the water is shut off at that location as well. It is important that the excavation of the main and the corporation be controlled to prevent any water from entering the corporation until the new service once it is installed. Inside the home, while the excavation continues outside, the employees inside the residence begin the disconnection of the lead service and prepare the new copper for installation. They also replace the water meter at the same time, since they already have access to the property. One of the more important steps in getting the new copper line ready for installation is the sealing of the new service before it is pulled. The end of the copper pipe is covered with electric tape. The pulling sock is then placed over the end of the copper pipe. With the pulling sock is a small rubber ball that is placed against the taped end of the pipe to further prevent any potential particulate from entering the new copper service during installation. Once the corporation is exposed, the excavation then moves to the curb stop. curb stop is removed, cutting the lead line on both sides of the curb stop. Then the line is thread through the lead line from the curb stop to the inside of the home, and then a 3-inch steel cable is pulled back through the service. So you first thread a line and then pull a steel cable back, and the steel cable will be the pulling instrument. So the copper pipe is connected to the pulling harness, and the harness is connected to the steel cable. They use the backhoe to pull the lead service out of the ground from the easement to the curb stop. There is special equipment that's available on the market for doing that pulling without the use of a backhoe in this fashion that's shown in this slide. Once the copper pipe is visible in the curb stop excavation, the process stops to allow the cable to be removed from the backhoe. And it is then re-threaded through the portion of the lead service line between the curb stop and the corporation. The backhoe then pulls the copper line through to the corporation excavation. From there, the new copper service is attached to the corporation. Once the copper is attached to the corporation, then the copper line is cut in the curb stop excavation, and a new curb stop is installed. The final step. They then provide a set of flushing instructions to the property owner for continued flushing of the premise plumbing. For each tap flushed, with each tap flushed for 5 minutes before the moving to the next tap downstream from the meter. If the customer requests it, a filter is provided for them to use for the next 3 months as an added precaution. The flush, they hand out this little notice which gives the detailed flushing instructions, where you can remove the aerator from all the cold water. Flushing instructions include removing the faucet aerators from all cold water taps in the home, and beginning at the faucet nearest to the meter, fully open the cold water tap and flush for 5 minutes, and shut off before moving to the next faucet, and repeat the procedure throughout. Until the flushing is complete, do not consume tap water, or open your hot water faucets, or use ice maker or filtered water dispenser. Clean the inside of your aerators before reinstalling on the faucet. So these instructions are an additional method to ensure that any lead is removed from the home's water supply. So they've got a lot of experience with this process. The next bunch of slides get into the detail of their replacement. This slide was presented earlier, and the following slides get into real detail. And all of these slides will be available from the Network Environmental Finance Center network within about a week, I think Tess mentioned. So I won't get into a lot of detail because I'm starting to run out of time. But just briefly, I'll show you. It's a lot of good information is contained in these slides, and if you're interested, I recommend you download this presentation afterwards, at least to get into these details, which is a lot of good information, just how to do it. Gets into the procedures, gives you details on both the curb stop location and the corporation location on the main. Gives you detailed instruction notes, schematics. It gives you a diagram and a list of materials required for the service line replacement. Again, detailed instruction notes and another diagram and list of material needed for that installation from the main to the curb box. And finally, some instructions on how to do it. There's other methods for the lead service line replacement other than what Lansing used, and they're shown on this slide. There's the open trench method, and then of course there's directional drilling, a pneumatic missile, line splitting, and then what Lansing used was the service line to pull and replace. And so there's YouTube videos available on all these methods, and it's so again, once in a week or so, when you can access these slides, you can have all of these links for connecting with the YouTube. EAGLE down there is on the bottom of this slide is the acronym for the new Michigan Department of Environment, Great Lakes, and Energy, a combination of three former departments, the DEQ, the Great Lakes and Energy. But these YouTube videos it's a source of good information. So I guess we've got a couple of minutes for questions, and here's my contact information, which will be available for download later. Thank you for your attention.
Yeah, I think we have time for a couple questions, and just before we get going with those, we like to do a quick poll, mainly because, as you may know, one of the services that the Environmental Finance Center Network can provide to small systems is free one-on-one technical assistance. So if you do have further questions about other techniques for lead service line replacement, or you would be interested in learning about options for your system specific to lead service line replacement, you can let us know here, and someone will send you a link to get more information and to potentially get matched up with someone who can help you. So I'm going to go ahead and close the poll now. The first question that we have for you today, John, is do you happen to know, you showed us a map of the lead service line replacement needs per the heat map of each region and where the most lead service line replacement was needed, and the Midwest was showing up as a hot spot. Do you happen to know why that would be?
Why? I've thought about that. Why was it all in the Midwest? And maybe it was just the period of homes being built. During that 1920 to 1940, there was a lot of homes being built in the Midwest, and there were lead mines in Wisconsin, and a few of the other Midwest states had lead mines. So maybe they were using their local products, or somebody was out there pushing some of the local products in the Midwest.
Right.
There's quite a few out in the Northeast also.
Okay, so then the next question. This question is a little technical. The question is about what contributes to lead leaching. So the acidity in water can often contribute to lead leaching, but then also lower mineral content of water can contribute to it. Do you happen to know why a lower mineral content might increase lead leaching?
I do not know that answer.
Okay. All right. Here's the question: is the trench cable pulling method that you mentioned for the Lansing example, is that the same technique as what is also called pipe bursting?
No, that's two different methods. And the video or the YouTube videos that I referred to would show the difference. Pipe bursting is literally breaking the existing pipe and pulling a smaller one through it. But the Lansing did not break the existing pipe underground, which pipe bursting does. Lansing actually pulled the old line out, the old lead line or galvanized line, whichever the case may be, and attached to that they had the new copper line. So they pulled the old line out, and behind it was the new copper line.
All right. And then you mentioned that there were some restrictions for the cable pulling method that related to, how deep or how deep down they were, and related to other things like that. Without digging up the line, in which case how do you know, essentially, how do you know if those restrictions apply to you, essentially, for what technique to select? If there's restrictions on that particular method, how would you know? Does that make sense?
Well, yeah. Well, those restrictions were, you may not know, but to get started with that method, you would first you've got to excavate at the curb stop, and then you're excavating at the corporation, at the main. So you've got to do two excavations, and that gets the process started. And if you have difficulty continuing, it may be because of you might find that the soils are too tough to do that cable pulling method, or typically it shouldn't be too deep for that cable pulling method. The depth shouldn't matter, but the types of soils that you have would be contingent. And if you found out you couldn't pull it, maybe there's some other utilities affecting the pull. So I guess it's trial and error.
Yeah, that seems to be a recurring theme. Speaking of that theme, this will be the last question. You had mentioned earlier how lead service line replacement can be a sales job, and we're getting a lot of questions about how can communities kind of work together with customers to essentially overcome the partial solutions, the partial line replacement, and to kind of get everyone on board to do the full replacements needed. Do you have any experience in how to kind of successfully get private homeowners on board, or communities, or all the stakeholders needed to do these replacements?
I do not have firsthand experience at it. I am on a small, a community, a city council person in a community of 7,000 people. And we're going to have some of those experiences. But again, I'm located in Michigan, where the state will allow us to use revolving loan fund money to pay for it on private property. So but where the private property owner is faced with paying it themselves, that it's going to take more of a sales job. And it's educating the general community and letting them know that they're saving, they're protecting the health of the youth and future generations in their community. And there's a national consensus that this is good to do, and of course there's always some hard nose out there who might be tough to convince. That's going to be.
Yeah, I think that kind of is a good place to end, because like you said, it is about safe and reliable water, and it is a challenge. So we are totally out of time for questions. I do want to just reiterate that if you asked a question and we didn't quite get to it, we'll try to respond via email. And then also we'll be able to send out an email that has a link to the recording of this webinar, as well as somewhere where you can find a link to download the slides. So you'll have this information to refer back to if you need. And I think on that note, John, do you have any closing remarks? Would you like to close us out today?
I'll say, have a good day, folks. It's cloudy and cool in northern Michigan. I hope it's more pleasant where you are.
All right, thanks so much. And let us know if you have more questions, or get in touch if you need more information.